Good day, and thank you for attending Blue Water's webinar, Cost-Effective Solutions for Stormwater, Inflow and Infiltration in Sewer Overflow. My name is CJ Strain. I'm the CTO with Blue Water Technologies, and I'm glad that you've been able to join us this morning for this conversation on stormwater treatment. For those of you whom I've not had the pleasure of meeting at local conferences, I'm a professional chemical engineer. My primary focus in wastewater is process development. And again, I focus on not only the process development part, but the product development part as well. And so I'm going to share with you some fairly unique stories today, and I believe very exciting product and technology changes for the future of stormwater treatment and overflow scenarios. The format for this presentation will be quite simple. We'll start with an introduction to the challenges, and we'll transition to a process technology that meets some of the challenges that we highlight. We'll wrap up with a Q&A for the audience, and for that purpose, there's a variety of ways that you can, well, actually primarily one. There's questions. If you look at your interface for the GoToMeeting interface panel, there's a location where you can type in questions. And at the end of the presentation, at the end of this webinar, we'll go through those questions and answer them for the audience. So let's begin with a brief discussion of the challenges with stormwater and CSO, SSO opportunities. I like to think of these as opportunities because the infrastructure throughout certainly parts of the East Coast and the Midwest has utilized combined sewers, and so with stormwater events there's a lot of challenges that go along with that, and a lot of those challenges include overloading of nutrients, solids, and then a change in the hydrodynamic properties of receiving waters. So you get particle entrainment and different scenarios like that. So with the storm sewers, etc., there's been a variety of ways to mitigate some of these challenges with either establishment of holding so that the water could be treated more slowly in the future once the rain event or the wet weather event has passed, or various scenarios like that. But what I'm going to really focus on today is the mitigation of the solids that is entrained by stormwater and entrained in discharge of the combined sewers to a receiving water. So we're going to discuss what I believe to be a very economic scenario, a very economic solution for that aspect of the problem. And I'm going to show how easy it is to retrofit this technology to collection systems without expansive redesign and construction, and how economically they are to operate and maintain, especially over a long life cycle. Here you see pictured is the EcoMat rotating belt filter technology, and I believe this to be a very ideal technology for managing solids in overflow scenarios. And as we progress through this presentation, I believe you'll see why I hold that opinion. Before I go into discussing the specific aspects of the EcoMat rotating belt filter, I'm going to describe some of the reasons or some of the design considerations for appropriate screening, especially in the pass-through treatment scenarios, often applicable to stormwater scenarios. So ultimately, you could tie all of this to economics. Again, the bottom line is going to be the capital cost, the cost to establish the treatment system, and the life cycle cost of the equipment for treatment of stormwater over the life of the equipment. So ultimately, we're looking at a treatment quality to address the problem, to remove solids from the treatment, the process water. And we're looking at simplicity is usually one of the primary key design factors, because the more complex the system is, typically the more expensive it will be to integrate and the more expensive it will be to maintain. So we want the treatment quality, but we also want it to be a simple system, easy to operate either automatically or by operators. And we want to facilitate the approach, the multi-barrier approach so that if there is system failure, it's very easy to have some level of redundancy or some level of treatment should failure in a single stage occur. And then ease of maintenance, safety, environmental controls, etc. Those will all tie in not only to, ultimately into the cost of the equipment, because the easier it is to maintain, the less expensive, of course, and safety hazards cannot be overemphasized. Safety is a huge thing. It can be extremely costly if appropriate design considerations are not tied into the treatment system. So all of these will factor into design considerations for screening a pass-through system for treatment of stormwater. And so please keep this in mind as we start discussing the rotating belt filter technology for treatment of stormwater. What I am proposing as a solution to the solids removal is the EcoMat rotating belt filter. I believe that this is an ideal solution because of its low cost of ownership. It has low upfront capital cost. It's fully automated. It draws very little power, and when it is not needed, the motors are completely idle. So this can be installed underground. It could be installed, within the collection system itself for screening. And again, when there is no storm event, when there's no water flowing to it, it is completely idle and not drawing any operational or not consuming any operational cost or input. Again, as I proceed through this webinar, you'll understand more and more of these benefits. But I want to share with you this first case history that we've put together for the city of Glendale, Oregon. We used a single EM3 basically to demonstrate this system. It's currently in design. But this particular plant has a 10x peaking factor with stormwater and wet weather events because of infiltration within their collection system, as well as having some combined sewer inflow into their system as well. So again, very high peaking factor for the system. And they wanted to mitigate all of the TSS, or at least as much as possible of the TSS, going into the treatment plant. Their goal was a deliverable of a minimum of 50% TSS, but obviously that wasn't going to do it long term. We knew that we would have to get it at least roughly 70% removal. So that was the target for performance in this application, and that was achieved with the appropriate design considerations on this project. An EM3 has roughly a 0.5 MGD capacity, so this was a fairly good flow for this design test. So here you can see in the chart there's both TSS and BOD graphed. And the TSS removal, you can see multiple points throughout the test period, averaging roughly 70% removal, and even on up to a high of 80 to 90% of TSS removal. That's with an influent of roughly 100 milligrams per liter going in, and so it'd be 30 or less milligrams per liter of TSS leaving the pass-through screen, this treatment system. And along with that TSS removal, you get a significant amount of BOD removal as well. Ultimately, it would be nice, of course, to hold below a 50 or below a 30 on BOD. And for this particular application, it was able to hold below a 30 BOD with roughly 50+% removal. Now, of course, it's going to depend on the BOD strength of the influent water going into the system. And a lot of times that's tied into what kinds of constituents the runoff might pick up, whether it's picking up oils and various constituents like that, and also the strength of the sewage that it's being mixed with before treatment, if any. So again, very appropriate treatment system in a pass-through screening application for combined sewers and overflow situations. I'm going to pause here and introduce you to more of the product, the aspects of the product and the product line that Blue Water offers for this scenario. So this video will show off, it'll begin with our largest single unit, which is a 3.5 MGD treatment capacity unit. And again, in a lot of combined sewer overflow scenarios, this might be installed in a concrete channel, which I'll get to later. But compare it to a conventional clarifier. The footprint is very minimal. So the space required for stormwater treatment is minimized as much as possible. And Blue Water has a complete product line ranging from a 0.5 MGD capacity unit up to that 3.5 MGD capacity unit that we just saw here. So again, we have 4 primary product models, and we're actually launching another model this year as well. But within the can, there's a cartridge, and with this video excerpt, you can see there's a tail roll and a head roll, and there's a drive motor off that head roll. There's dirty water, stormwater, sewage coming in the influent area of the channel, and this is level controlled. So that'll drive the VFD of the drive motor. The belt speed, there's a continuous loop mesh mounted on this cartridge, and this belt speed is variable. And it is used for screening, filtration, and transportation of the thickened solids from the unit. So as this belt moves, it'll screen and filter particles. The faster it moves, the thinner mat formation will get, the less filtration, and you'll get screening basically to the particle size of the screen plus some. If you slow that down, you form a thick filter mat. It's a porous mat that can remove the larger particles, and you'll get finer and finer solids distribution in your effluent water. So this package, this cartridge, can again be mounted in a steel containment like this, which is fully contained for odor control, etc., and conveyance of sludge. So the sludge is moved by a screw, and there's integrated and optional dewatering that can be integrated on all of these systems that can take it to roughly a 30 to 35% dry solids. Now this is, again, possibly more appropriate for primary treatment at the water treatment plant itself, but it is an option for the stormwater treatment within the collection system as well, depending on the need. I would expect that most of the time the dewatering unit would not be a part of it, and that the filtered or the removed solids and particulate would be transported to a wastewater treatment plant or for other disposal. But the scenario for stormwater treatment is very appropriate here for the EcoMat rotating belt filter, because you can take that cartridge and you can mount it in concrete channels like you see in this diagram here. These can be, again, they can be mounted underground. They could be mounted within low points within the city for gravity flow to a central treatment flow-through treatment plant for the solids. And again, these are idle, completely idle when there is no flow. The water would have to fill the channel and produce some head for the level sensors to generate or to, through the PLC, tell the motors to start moving that belt and operating. So again, zero power, zero cost input while there is no storm event happening and occurring. And this footprint is roughly sized for a 100 million gallons per day plant. There's 32 cartridges within this layout. Compare that to a conventional clarification footprint, and you have roughly a football field or more of conventional clarifiers for the same level of hydraulic treatment. So you have, again, the EcoMat would fit within this building. You're eliminating so many different costs. Earthworks cost elimination, the capital minimization is going to be key, and then all of the operations and maintenance costs as well. So that's just a brief introduction to the EcoMat product line. And now I'll go back to the presentation and discuss some more of the key functionality of the equipment as well. So the EcoMat rotating belt filter, just to give you a little bit of history, Blue Water has been offering and supplying rotating belt filters to the market for about 7 years now. The EcoMat product line was an improvement over what was previously offered and was launched in 2012. New models, we're actually launching another 2 new models this following year, which I'll highlight within the presentation. But really what's key to this product line is the ease of operation. Blue Water's made several improvements to make the operations and maintenance and cost of ownership much more reduced over what was previously available on the market. But all at the same time keeping the small footprint of the treatment capacity, the modularity for any level of treatment from like a 5 gallon per minute flow up to 100 million gallons per day flow. These are very appropriate for very small and extremely large flows as well. There's typically no chemical required for operation. Usually the only scenario where there is chemical required is it's an industrial application where higher capture rates are required. So obviously when we're talking about stormwater and even primary treatment within a sewage treatment plant, you're not going to be using chemical in, I would say, 99% of the applications. What that does for you, this treatment system, the EcoMat rotating belt filter, will provide increased aerobic capacity within a treatment plant, as well as provide a cost-effective way to manage those peaking factors that would otherwise be quite troublesome with combined sewers, overflow scenarios, and stormwater treatment. So I'm covering very broadly a variety of applications for this technology, but very well engineered, very proven track record, and this is a U.S.-made product. So we can provide this equipment with a very low lead time, very short lead time, and we do have contract equipment available for contract treatment as well for storm and disaster events and mitigation of water in those scenarios. So again, I want to highlight the specific mechanism behind this technology, the EcoMat filter, and why it's able to capture so much solids. Again, in stormwater scenarios, we're aiming for a very high capture rate, between 70 and 80%, with what is basically a rotating screen on a cartridge. And the reason why we're able to get such a high capture rate is because of the way this is integrated, and controlled within the rotating belt filter. So again, there's a cartridge mounted within a can, or it can be mounted within a channel, and it can be an array of cartridges as well. But the way each of these cartridges operates is there's two rollers on this. There's a tail, roughly it's a tail roll, and then there's a head pulley, and this is actually what is driving the belt. There's a motor attached to this. So on this cartridge is a continuous loop mesh. Typically we're looking at like a 300 to 350 micron mesh for sewage applications, but when we're talking about stormwater and overflow scenarios, we want to tighten up that micron pore size. And in that reasoning will become apparent as I continue through this discussion. But we typically go down to between 100 and 150 micron mesh for those applications where stormwater mitigation is important, because again, that enables us to have a higher capture rate. And the reasoning is behind the mechanism for removal here. So think of this as your continuous loop mesh. As the clean mesh comes around the bottom of that tail roll here and is first exposed to the dirty water, you get screening basically to the particle size of the mesh. And you quickly will blind, well, not completely blind, but you'll quickly build up a porous filter mat that will give you an effective, a much lower effective mean pore size through that mesh and through that filter, porous filter mat that builds up. So your particle distribution will drop significantly and drastically, and you're effectively filtering the water that comes through the system. So that's the reason why we're able to get capture rates up to 70 to 90% of TSS. And the real mechanism behind operation of this technology. And the nice thing is you have built-in sludge conveyance as this belt comes up the cartridge. The solids are discharged into a sludge conveyance system. And this cross section, it's a bin with a screw press in it. That can be a variety of different options. It can be a bin where you have a sludge pump, basically pumping the sludge to a central dewatering system or some other management system for the sludge. So that's the basis of operation behind the EcoMat rotating belt filters. I do have another video that I want to share with you that'll highlight this functionality for this system. So this video is a 0.5 MGD EcoMat, which is an EM3. This one here is operating at capacity. This is actually typical domestic sewage at a wastewater treatment plant. So a little thicker than we would see in a stormwater scenario. The TSS is about 250 milligrams per liter. And this unit is operating with a 300 micron mesh. But again, operating at capacity, you can see the level of capture that this system is capable of achieving. You have all of the sludge being collected, matted, and used subsequently as a filter to capture more solids, conveyed up and discharged into the sludge collection bin here. Now there's an integrated auger within this system here, which will begin to dewater the solids, which is an option again for the canned stainless steel enclosed units. And this dewatering is very capable of very dry solids. That's roughly 35% dry solids there. So again, an EcoMat in operation at capacity on a municipal sewage plant. The operations are very similar when we're talking about combined sewer overflows. The key difference would be your influent water is going to be probably half the strength or less with combined sewer systems and relative solids. And we're going to go with a tighter micron sieve on that mesh so that we get higher capture rates. This next video I have included here to demonstrate how capable of this system is at taking very high slugs of solids, or slugs of very high solids concentration. And we use this technology on industrial plants a lot as well. Again, it doesn't apply at all, or hardly at all, to a stormwater treatment scenario, other than to show you that it can take a very high amount of solids and still maintain treatment levels. So this is actually a processing plant, a food processing plant, where they're taking a very high solids waste stream, very high in fog, very high in solids, very high in BOD, and they're flocculating and removing the solids from the stream using this rotating belt filter technology. So again, just showing this video to demonstrate that it's very capable of high solids removal and very sustainable in that scenario. You know, cleaning systems integrated within the unit are very effective for cleaning and treatment. In addition to the innovative process, I want to point out some of those other key points that I referred to in those videos, a few other key features of design. And for that purpose, I have a couple of pictures looking inside of a unit at a cartridge. And again, this can be a concrete channel with multiple modules. The screening material is a looped polyester mesh. And again, the effective sieve size can vary significantly depending on the application. It's a self-aligning belt, and the belt life is anywhere from 1 to 3 years. And here you see some of the cleaning mechanisms, and actually there's a better shot of it on the next slide here. For belt cleaning, we have a couple of options, actually several options. Some are static, some use a pneumatic system or a pressurized water line for pressure spray bars and intermittent degreasing, which you see here in this picture. This degreasing aspect is very effective at keeping the mesh clean and mitigating any oils in solution. We have these installed not only in stormwater applications, but also in municipal plants where there's a lot of restaurant grease that comes down the line, as well as scenarios at like meat packaging plants. which are conventionally very high or traditionally very high in fog, fats, oils, and greases. And these cleaning mechanisms are very well designed, and again, there's options for each of those scenarios to make sure that the client, the end user, has the most effective system possible. So back to the full range of product line and their flow capacities. We actually do have a small model that we use for small package plants, membrane plants, RBCs. That'd be the EM1. It has a 0.1 MGD capacity and a very small compact footprint. So again, I believe that the compact and very effective treatment is going to be one of the key benefits of this technology for these applications. The next unit up is an EM3, which you saw in the videos. It's a 0.5 MGD capacity unit, very small footprint as well, 5 by 5. We do have an EM10 for 1 MGD treatment, an EM15 for 1.7, and then our largest unit is a 3.4 MGD capacity cartridge. And again, this can be installed in cans. It can be installed in channels. That's what these different letter designations stand for. There's a simplex, which is a single cartridge unit. We do have a duplex option, which basically has 2 cartridges in a single unit for built-in redundancy. And then we have the channel mount unit, which can be installed in multiple modules, for stormwater treatment or for large sewage treatment works. So again, these are highlighted within this matrix here, the different models with their flow capacities, both in gallons per minute and MGD, and their footprint requirements. With the larger units, our largest unit, the EM30, which again is a 3.4 MGD capacity, is roughly a 60-inch wide cartridge, and so that'll give you an idea of as to the size of these cartridges installed in a channel. There's a lot of different applications that we've used these in, these rotating belt filters. Primary wastewater treatment's a big one, especially where there's combined sewers, high fluctuating flows with wet weather events. They've also been used a lot for membrane pretreatment. Anytime there's a membrane plant that can, especially with storm events, they pick up so much particulate, plastics, etc., where that can be a huge problem for membrane plants and other plants that just have issues with solids entrainment and high flows. So again, they've been used for membrane pretreatment to protect the membranes. These rotating belt filters will remove all the hair and different things like that are problematic in those scenarios. We've also used these in agriculture, aquaculture, dairy, pulp and paper. I showed a couple of videos, and one of those was actually from a dairy plant. Very applicable for textile applications, scum and sludge thickening, another application. And the nice thing is these rotating belt filters does all the grit removal, which, depending on how the plant is configured, you might want to have a separate grit chamber if there's an on-site digester, for example. But if that's not a consideration, then it can be used to do the plant grit removal as well. So there's a variety of applications, and as I alluded to earlier, each of those applications, or we can customize the equipment for each of those specific applications slightly to maximize the capture rate and the efficacy of the equipment in that scenario. So I mentioned that a 300 micron sieve is typical for sewage treatment. When we're talking about CSO applications, we're going to go with a slightly tighter sieve, maybe a 150 micron sieve. But there's a lot of different scenarios where we can make adjustments to that sieve to provide appropriate treatment, screening, and capture rates. You see fisheries and desal, they'll use a slightly tighter micron sieve, whereas pulp and paper, you might have up to an 840 micron or 1 millimeter sieve screen. Here I wanted to share with you some pictures from our production floor, different models in production, just to give you an idea of the different sizes of each of these models. I shared with you the footprint, but sometimes, a picture's worth 1,000 words. These are EM3 units, so again, 0.5 MGD capacity units. And this one here against the wall is an EM10. So that's rated for 1 MGD of treatment for municipal sewage. A couple more pictures from shipping and production floor. Again, all of these units are made in the USA, so very short time, short lead delivery for any of these units, and they are available for contract treatment as well. This specific unit here in this slide was fully integrated for contract treatment, for pilot treatment, and for long-term leases. So what you see here is a 1.7 MGD capacity unit. This was trailer mounted basically for disaster scenarios. You see one of our technicians on our shop floor integrating it for piping, flow meters, controls, etc. And you see here in the upper right the SolidWorks model exploded view for the system as well. So you have the can, integrated cartridge, drive motors, and various control instrumentation integrated within each of these units. I mentioned that we launched a couple new products this year. This is one of them. It's an EM1, which is definitely on the smaller side, especially when talking about stormwater treatment. But not knowing, every possible scenario that might arise, I thought I would share it with the audience today. This is rated only for a flow up to 75 gallons per minute. So probably more appropriate for small package plants, very small communities, maybe even housing developments. But basically, this unit is set up as a low-cost product within this line for those smaller communities. This is an EM3 model, from SolidWorks, and you can see it's fully integrated with piping, plumbing, drive motors, etc., and it has integrated dewatering. To reduce costs and provide a more low-cost item for the smaller applications, the more cost-conscious client, if you will, we've got this EM1, which does not have integrated dewatering. It's a much more streamlined model, has a very simple control system on it, but it gives you the same or similar level of performance regarding water treatment. So there's, again, to reduce the cost and provide basically a baseline piece of equipment, although it does have options, we've cut weight in some of those options for the base model. Again, this is great for small flow industrial treatments, pilot or contract treatment scenarios. You can fit this easily within the back of a truck. I mean, you see one of our technicians standing next to it. And again, this will treat up to 100,000 gallons per day. So a nice high capacity with that small footprint. And again, ideal for protection of membranes in small package plants, RBCs. You get so many fouling issues with those kinds of plants that you put an appropriate screen up front of them and it'll remove a lot of headaches for the owner and the operator. Now that I've talked about the equipment and given you a pretty good background on that, I want to share with you a couple of case studies that illustrate with data sets the level of performance capability, and these are mostly on municipal sewage plants. So a little thicker streams than you would have with stormwater, but again illustrating the level of performance that this system is capable of. So this first case is from Post Falls, Idaho. Post Falls is in a 10-year design cycle for improvements. They currently have no primary treatment. They have screening going to their secondary, and they know that they have to upgrade from that in the coming years. It might come sooner than 10 years, I'm not sure. But they took this equipment on site to do some modeling and preliminary design work with a 0.5 MGD capacity unit. The deliverable and goal was 50% TSS. They don't have a digester on site, so they were looking for screening and grit removal as well. In the left-hand side here, you see a chart graphing the TSS removal. So you see the influent TSS averaging, in the high 200s. In this particular application, we averaged just over 60% removal of TSS. So, and another thing I always like to point out is the dampening effect that you see with treatment. So you see quite a bit of variability within the raw wastewater for the TSS level. With that 60% removal, you also see a dampening again of that variance, so it doesn't vary as much, and that's definitely a big help to the sustainability, the reliability, and consistency of the biological treatment downstream. Here you also see illustrated the BOD removal, not as many data points within this set, but anywhere from a high 200, maybe a 275 average, down to a 175. So again, the average BOD removal for this particular plant was about 37% BOD removal. And again, that the TSS capture rate, the BOD removal rate, can be adjusted depending on design considerations such as loading rate and sieve size for the system. Here's the last case study that I'm going to share with you. This is another treatment plant in Plummer, Idaho. This particular plant had a pretty interesting story to it. They had screens installed. It's a brand new plant, but these screens are static screens, and they have no cleaning mechanism with them. It was a slight design oversight, either with the equipment supplier or with the engineer. But basically what the owner of the plant has to do on a daily basis is they have to get up on a ladder, which you see tucked away just behind this column here. They have to get up on this ladder with a high-pressure hot water wash system and manually spray those screens down every single day. So not only is that costly from an operations and maintenance standpoint, but at some point there's going to be an accident. You know, those are just bad operational practices. There's going to be an accident, there's going to be a safety violation, and that, of course, is going to cost money as well. So the owner of the plant is looking into options to replace those screens with an automated system that will be safer and require less maintenance. What Blue Water did was we took one of our contract units, which again is trailer mounted. This is a 1.7 MGD capacity unit, the EM15, and their design flow for the plant is a 1.1, so it took their entire plant flow. Their goal was to get TSS removal, their screening and grit removal in an automated system. So here you can see their influent TSS. They're on a lift station that's on-off, so they have quite a bit of variability in flow, as well as in their influent TSS level due to that lift station being on-off. Again, you can see the dampening effect after treatment, and again, this particular scenario averaged about 61 to 62% TSS removal of that raw water. And then the BOD removal associated with that is between 30 and 40%. This one in particular averaged roughly 37%. The screen on this one was a 300 micron. So again, you can adjust the level of TSS capture, level of BOD removal, by making that either a more porous screen, where you're just essentially using it as a screen and don't get as much filtration, or you can get put a smaller screen on it where you'll get a more rapid and a thicker mat buildup, where you're getting higher levels of filtration and removal. So again, a nice case study. Most of our projects that aren't contract, that aren't pilot or going into design, especially industrial, they start with bench tests, and then they'll go into a pilot phase in further design. And so this is an industrial application of one of our bench test and pilot scenarios. You can see raw water. This is actually a whey digested stream, but it requires polymer. As I mentioned before, very few of our applications do require polymer, and most of them that do are industrial. So you can see the level of clarity that you have after treatment. This was actually a pilot sample grabbed, or a sample grabbed after treatment on a pilot scale. So our bench scales, they look similar to what you see here in these pictures. They're just sieve discs that we use to size the micron mesh for the appropriate capture rate of the solids from the process stream that we're intending to treat. And that the micron size will depend on particle size, desired capture rate, and various other operational aspects and properties such as those. But what we're looking for when we do these bench studies is a nice porous mat formation, a nice thick mat formation, and then we're looking to measure how much water that mat will pass prior to plugging. Along with these treatment systems, a lot of times there is a desire or a need for dewatering. So Blue Water also has a line of screw presses, our Blue Press, for sludge dewatering. And there's a variety of different applications that you see on the screen for which we've used this product line. But primarily we have these with the topic of the day, the stormwater treatment, sewage treatment. We have these integrated with the EcoMat rotating belt filter systems, either mounted to the unit or in a centralized location where multiple cartridge modules can have their sludge pumped or conveyed to a dewatering system for dewatering. And these will pretty consistently get between 30 and 40% dry solids on primary wastewater or primary sludge and screenings scenarios such as the ones listed on this sheet. Blue Water produces each of these cartridges, rotating belt filters, the EcoMat product line in our manufacturing facilities in the United States. So everything is U.S. made. We have our own UL listed panel shop. We do all of our own control systems and automation. That gives us a lot of flexibility to customize for specific clients. It's very easy for us to do mobile contract treatment plants even, as you see in the upper right pictures here. We produce fully integrated control containers that have PLCs, climate control, desk space, operator space to work and live for a contract treatment. So those are just some of our capabilities domestically here in the U.S. for our product lines. And as I mentioned before, a lot of our new projects, they begin with a bench scale test, and they go into pilot scale treatment for further design. And there's also a lot of, as I mentioned before, contract treatment that we do with our mobile pilot systems. So you can see some of those systems in these pictures here. This is our sand filter line. We have a DAF line, and in the lower left here, you see the rotating belt filters. This is out for contract treatment at a plant that had, there had been a rain event. They had storage capacity, but they needed to treat what was stored. So they had contract treatment for about 1 to 2 weeks with this. It's a 1.7 MGD capacity unit. You can see the pump and the control panels just put on a gravel pad next to their treatment plant to treat that stored volume. So really, to summarize the application, stormwater, overflow scenarios, treatment of that, those challenges, those problems, those water sources with the EcoMat rotating belt filter. Conventionally, you're doing it with screens, and a lot of times those screens aren't fully automated or are not completely appropriate for the level of treatment that we would like for stormwater treatment and for overflow scenarios. And the other option is primary clarification or some other tankage. But really, with that, you have a lot of cost. There's the footprint for conventional clarifiers or even conventional screening. And with the large footprint, you have extremely high cost for earthworks and installation costs, including all the pipe work, etc. And then you have the power and life cycle costs to maintain that system. And the economics of redundancy. If you have a big clarification system, for a redundant system, you need a completely 100% duplication of that footprint, or at least the smallest, or a replication of the largest, actually, unit within that footprint. So if you had like 9 clarifiers, you would have to have a tenth for your redundancy. With the EcoMat rotating belt filters, the economics are so much more appropriate for the client and the end user because it has such a small footprint and modular equipment cost to begin with. So you get all of this cost reduction with the EcoMat rotating belt filter. Now with that, I'll open the floor to questions. We have about 10 minutes left within our hour for questions, so you can type your questions in at in your interface panel with GoToMeeting, GoToWebinar. And it looks like I have a couple of questions here. I'm just trying to open up my view to make these bigger. Okay, so I have several questions here. So one of the questions is, how important is it to have good grit removal ahead of the screen? Is it a danger to have grit tear the screen against the cleaning mechanism? So basically, these units are used for grit removal. It's less of a consideration on the equipment, the rotating belt filter itself, as to other ancillary plant design. The unit itself can handle grit very well and can get you all of the grit removal that you need. But what the question of what is going to be done with that sludge is really the most important factor. If it's going to be sent to a digester, or if you don't want the grit in your sludge, then you want to have a grit chamber to remove the grit before screening. So I hope that answers your question there. There's multiple questions here, so if you just bear with me here, I'll try to get to everyone. So there's a question on, have these filters been used at coal power plants to filter out coal fines and stormwater runoff prior to discharge to receiving waters? And the answer is yes. We've done a couple of projects like that. You'll need an extremely fine filter mesh, and I guess that's all the answer that I have for you is you need a very fine filter mesh. So if we had a particle size analysis of the stream, and usually they're quite small, you know, I would say even in the 10 micron range. But these filters have been used in that scenario before, so it's something. If you want further information on that, please email me with the address on the screen there. There's several other questions regarding some project-specific applications, and I would prefer to handle those offline. If you contact me directly for those, I would prefer to have the conversation. There's a lot of specific design questions that are being asked, and I would like to handle, again, I'd like to handle those offline. One of the questions is, as a ballpark, how much does the largest unit cost? And I'll just pull a big round number out of the air. Most of the larger systems, the 3.5 MGD cartridges, it really depends on the specific application and how the unit is rated hydraulically. But I would say that a ballpark between 250 and 350,000 is a good placeholder for the equipment itself. Now, with larger projects, obviously that price goes down because the control systems and the ancillary instrumentation, that price is spread out over more units. Also, when you're talking about concrete channel design, you're talking about cartridge integration, and you have less ancillary. You probably would have a centralized dewatering unit, control system, etc. So there's a few different scenarios like that. So again, if you want further information on that, I'd love to have that conversation with you one-on-one. We are about out of time at this point. I want to thank everybody for joining me today on this webinar. It was my pleasure to host you and to tell you a little bit more about the EcoMat rotating belt filter. So I hope that all of your questions have been answered. You can find more information on the equipment line on our website, bluewater-technologies.com. I am available by email or by telephone if you want to get a hold of me and talk about a specific project, or if you have any specific technology or process questions that you need an answer to. So again, thank you for joining me today on this webinar, and I hope to see you next time.